Uh, in the topic Fourier series, up to now we have seen Fourier series expansions for the period 2 pi and for the period 2l. For the period 2 pi, we have considered two intervals 0 to 2 pi and minus pi to pi. And for the period 2l, we considered the intervals minus L to L and 0 to 2L. Now, in this video lecture, we will see Fourier series expansion for even and odd functions. And even and odd functions can be checked only in the intervals minus pi to pi and minus L to L. See, here the intervals 0 to 2 pi and 0 to L, they are not workable, and therefore we will see the Fourier series expansion for even and odd functions in only the intervals minus pi pi and minus L. So here we take the reference from the properties of definite integration. That is, in the property, one of the property says if the function is even function means f of minus x is equal to fx, then integral minus pi to pi fx dx becomes 2 times integral 0 to pi fx dx. So we have taken this for the reference. Therefore, for even function in minus pi pi, f of minus x is equal to fx and a naught is equal to 2 by pi integral 0 to pi fx dx. See, fx is even, therefore we have used the definite integration property. And an is equal to 2 by pi integral 0 to pi fx into cos nx dx. Why? Because fx is even, cosine function is also even into even, that is even, therefore total fx into cos nx becomes even, and therefore an we have taken as 2 by pi integral 0 to pi fx into cos nx dx with the help of that definite integration property. And bn is 0. Why? For odd function, integral minus a to a fx dx is equal to 0. And see, in bn, in the integrand, we are having the product of fx and sin nx. So fx is even, sin nx is odd, so even into odd, that is odd, and therefore bn will be 0. Similarly, for odd function in minus pi pi, odd function means f of minus x is equal to fx. F of minus x is equal to fx, that is, I will correct this. F of minus x is equal to minus fx, and therefore a naught is 0, an is 0, bn is equal to 2 by pi integral 0 to pi fx into sin nx dx. See, for odd function, a naught is 0 because a naught, in the a naught only we have considered the integration of fx. Fx is odd, and therefore by property of definite integration a naught will be 0. An is also 0. Why? Fx is odd, cos is even, and therefore odd into even becomes odd, and therefore again by that property uh, an will be 0 and only bn remains. And what is bn? Bn is equal to 2 by pi integral 0 to pi fx into sine nx dx. Now we consider the interval minus L. So for even function in minus L, exactly on the same way, Bn will be 0 and A0 is equal to 2 upon L integral 0 to L fx dx. An is equal to 2 upon L integral 0 to L fx into cos of n pi x by L dx, and Bn is 0 as I have already told you. And for odd function, that is not mentioned here, but what will be that? Because of the limited space I have not mentioned here. So what will be that? For odd function in minus L, exactly on the above part A0 and An will be 0 and only Bn remains, and value of Bn is 2 upon L integral 0 to L fx into sine of n pi x divided by L dx. We will see the examples on this particular article, that is examples on even and odd function. Our first example is find the Fourier series expansion for fx, where fx is defined as modulus of x in minus pi pi. So here f of minus x is equal to modulus of minus x, and modulus of minus x is equal to x, and x again we can write as modulus x, but what is modulus x? That is equal to fx. So finally we get f of minus x is equal to fx for fx is equal to mod x, and this concludes that fx is even function, and therefore we write the answer, that is the required Fourier series expansion for the given function, as fx is equal to a0 by 2 plus summation n takes values from 1 to infinity an cos nx, that is 1, where a0 is equal to, what is a0? 2 upon pi integral 0 to pi x dx. Why we take x? Because for x is greater than or equal to 0, modulus x is equal to x. Why we consider x greater than or equal to 0? Because our limits for the integration of a0 are 0 and pi, that is greater than or equal to 0, and therefore modulus x is equal to x, and the value of this integration after evaluation gives a0 equal to pi. Next, an is 2 upon pi integral 0 to pi x into cos nx dx. To evaluate this integral, we use our generalized bipart rule, very popular rule. By that rule, we are having an equal to 2 pi x into sine nx by n minus 1 into bracket minus cos nx by n square, and the limits are 0 and pi. Since sine n pi is 0, sine 0 is 0, and cos n pi is minus 1 raised to n, cos 0 is 1, therefore an becomes 2 upon pi into bracket minus 1 raised to n minus 1 divided by n square, and bn is 0. Why? Because our function is even function, and putting these values of a0 and an in equation 1, we get fx is equal to pi by 2 plus summation n takes values from 1 to infinity 2 upon pi into bracket minus 1 raised to n minus 1 divided by n square into cos nx. That is fx is equal to modulus x pi by 2 minus 4 by pi. After expansion, what we will get? Pi by 2 minus 4 upon pi 1 upon 1 square cos x plus 1 upon 3 square cos 3x plus 1 upon 5 square cos 5x plus and so on. Why? Because minus 1 raised to n minus 1 is equal to minus 2 if n is odd, and minus 1 raised to n minus 1 is equal to 0 for n is even, and therefore for n is equal to 2, 4, 6, 8, etc. These terms will not appear. One can ask the question for deduction also, that is to show that pi square by 8 equal to 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square, or pi square by 8 is equal to summation 1 upon 2n minus 1 bracket square, n takes values from 1 to infinity. So how you solve this deduction? Put the value of x is equal to 0 in the above answer, that is in equation 2, and modulus of x is equal to 0. When x is 0, modulus x is equal to 0, cos 0 is also 1. So therefore, putting all these values in our equation 2, we will get 0 is equal to pi by 2 minus 4 by pi into bracket 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square plus and so on. And after simplification, this finally gives pi square by 8 is equal to 1 upon 1 square plus 1 upon 3 square plus 1 upon 5 square plus and so on, which in term finally reduces to summation 1 upon 2n minus 1 bracket square, n takes values from 1 to infinity, the required deduction. Thank you. Stay home, stay safe, be connected.